Hello everyone. In this video, I'd like to talk about off delay time relay. Often we call off delay timer. After that, I'd like to talk about the on the PLC, the TOF, off delay instruction. I focus on this because there's something really special with the off delay, which can also be easily overlooked. All right, just give me a chance. I'd like to review a little bit on the timer. All right. So as you can see on here, you currently seeing a slide about relay, but actually a timer is a special type of relay, right? So I want you to look at the structure on the relay. So we have coil over here. Represented by A1, A2, that's the terminal, the coil, right? So once we apply the voltage or current on the coil, it will generate the invisible electromagnetic field, right? So that will start a series of action, right? Make the armature move, and eventually it will drive the contact open or close, right? So that's basically the how the relay operate on the contacts, right? So that's why relay is a electrically operated switch, right? So timer is the same thing, right? With on delay, it's easy to understand, right? So on delay is that when you apply the power supply to the coil, the action is being postponed, right? So the contact will take some time, change from open to close or change from close to open, right? So that's on delay. That's not very difficult to understand. But with off delay, remember off delay start when the power removed from the coil. So imagine you can see here. So when A1, A2 lose power, the timer start timing. And then eventually after preset time, the contact will open, close, according to the definition, right? So that's the off delay. Often there are some questions from my students asked, so how that operate? How the off delay operate without power to go into the coil, right? So that's something we can first investigate, right? So on here with Google, you can see we have a lot of off delay timers. We can have a look at some of the details, right? So first one I want you to look at is this. So this is a off delay, and if I zoom in on here, you will see on the right hand side on here, right, on this side, all right, you will see the pin arrangement, pin out on the off delay, right? Notice this on this, I cannot move my cursor right now, right? So, but you can see on the picture, right? So between the pin number 2 and number 10, you can see that's L1, L2, that's the power, right? And pin 1 and pin 11 is the shared contact, right? So it will, for example, the pin number 1 with pin number 4 is normally closed. Pin number 1 with number 3 is normally open, right? So that's the off delay, right? Of course, they have different name, right? I already talked about that in different video. So, but if you look at on top, on pin number 5 and number 6, there's a control switch. So that means even though this is a off delay timer, but the power is applied to the pin number 2 and number 10 all the time, right? So the power supply is there all the time, right? So the trigger is from the 5 and 6, the control switch, right? So this is more like a cheated version, right? So it doesn't really remove the power to the timer, right? With the 2 and 10 permanently connected, it only start the timing from the 5 and 6, pin 5, pin 6, the trigger. So that's why this type of time delay is called the signal off, right? So you see the other version, right? So, but anyway, right, this is one type of off delay. right? We can call this signal off. So there's a signal to trigger the off delay time. So this is nothing really special on there, right? So let's look at the second one, right? So you can see the second one. I can open this page. This is from the same manufacturer. You can see here, same manufacturer. But this time you can see here, right? There's no 5 and 6, it was before, right? So that's the control switch. And this one, it has only pin number 1 and number 7, right? So that's the power. So that's the power supply to the coil. And in the same time, it's also the trigger. So that's why if you notice below on the picture, 120 volt AC DC, and then below that it says true off delay. Okay, the one I showed you before, you can see here, it doesn't say true off, it just say off delay, right? Because it's based on the trigger control switch. But the second one I just show you on here, they specifically tell it is true off delay. Right, so this is mostly the question for, right? If it's true off delay, once we remove the power on the pin number 2 and number 7, how this type of relay, this timer can keep running and take the action after certain periods of that, right? Like this one, you can see the timer range 0.05 second to 30 minutes. Wow, it's really long, 30 minutes, right? So how does the off delay timer do that, right? So then let's do some more research. This one I get from the Schneider Electric. Right, so that's their website. There's a question: does Schneider Electric offer the true off delay? So you know what's the true off delay, right? So there's something I want you to read. All right, so on here, it specifically talk about this. Right, for an off delay timer to work correctly, it is necessary either one type is like connect a permanent power supply to the timer. So that's the one we look at before, right? It has permanent power supply. So that's can also be called on the signal off, right? Or you can see here, or design the timer such that it can self-power for maximum off delay time, right? So this is what they call the true off delay. So look at here, the self-power energy usually stored in the small capacitor within the timer, right? So that's one of the solution, right? We know with capacitor, right? So this is from the other website, right? With the capacitor, it can store the energy in there, right? So you can see here. So currently we're looking at the resistor in the parallel with a capacitor, right? So this resistor we can consider as the coil, right? So the you can see here the charged capacitor can discharge through the relay coil. So that's how the off delay timer can operate in this way. So there are many different ways, but this is one way, right? So when the trigger is closed, power go into here, right? So that will energize the coil and also charge the capacitor. But when the switch open, the stored energy will be released or discharged from the capacitor through the coil. So that will maintain the timer keep going, right, with the off delay, right? So this is one of the solutions, all right? On the same website, all right, I also present a very, very interesting solution without even not without without electrical, right? So let's look at here. So since we're here, right? So if you look at on this picture, this is a pneumatic timer. It uses bellow, right? The bellow is bellow is here, right? So this is basically it's a sealed container, right? Very flexible, right? So it's all sealed on here. So when the power applied to the coil, right? The rod A, that means here, it will go to this way to hit this part. So when that happens, this whole bellow, right? This whole structure will be pushed in this way. So as the bellow being pushed in, all the air inside will go out. This is a check valve. That means the air can go out only one direction. So that's air can go out, being pushed out, right? So in the same time, when the bellow move in this direction, you can see here that has mechanical link. Will make this contact change from this is was normally open will become closed, right? So this has happened when the rod being pushed, when the power being applied to the coil, right? So when the power is removed, right, this one will not pushing against the bellow anymore, right? Will be away on there, and then in the same time you hear in the mechanical assembly there's a spring. So that spring will try to push the bellow back to the original place, right? But over here, this is check valve can only let the air go one way. So the air can only go through this inline on here. All right. So also plus this is like an adjustment, right? You can make this opening wider or narrow, right? So that will adjust the time. But eventually the air will go in through this little small opening, right? And that will maintain this bellow to go through here, right? Because because spring started, and then the air will adjust how long it will take the whole process to get back to this location. When the bellow get back to this location, this contact was closed before, then it will become open again. So you can see in this whole process, there's no electrical involved. There's no electrical capacitor, charge or discharge, right? So this is just very interesting. I want to know, right? Not only you can use capacitor, you can use other different ways, right? You can use pneumatic to do that. And also, I think I read something there also, if you have maybe a battery built-in with the off delay, or maybe you can use the electronic circuit to do the process. But anyway, right? So this is, I just want you to know that the off delay, how the off delay operate without power supply to the coil, right? So this is what I need to know so far. The other thing I want to like to get your attention is that over here on the Schneider website, it has, in order to charge the capacitor in the timer, there are two operational conditions, right? So let's look at there, right? So if the device has been stored or unused, deactivated for a very long time, or it's like off the shelf, right? Haven't been started, haven't been energized in the circuit. For the first time, right, you need charge that at least 15 seconds in order to activate it, right? That's understandable, right? It has been put on the side for a very long time, right? So you have to first energize the unit, the timer, for at least 15 seconds in order to make the capacitor start to active, right? So that's the first time. Then you can see here, subsequent of the operation require that apply at least 1 second. So that means the first time or for a very long time have been used that you have to charge the capacitor for 15 seconds. But even that you will still continue using that timer in the circuit, still if you power on for the first time, you need to have 1 second on for the coil in order to make the timer ready to run to operational, right? So in order to correct operation on the removal of the control supply, right? You can see here, failure to observe this precautions will result in the some misoperation, right? So that's something you don't want to happen, right? So in some other off delay timers, I saw a similar, very similar conditions on that. So you understand this is because the capacitor, right? So if you want connect to something, right, that you have to charge to energize the capacitor for a period of time in order to let the delay operate, right? So I emphasize this is because, of course, this is very, very important for the physical timer in the electrical circuit to understand that. Also, it has some implications with the PLC off delay instruction. So you'll see what I mean by that. All right. So so this is so far this is about the timer relay, right? So the physical timer. So from now on, I'm going to talk about the equivalent function in PLC, which is the TOF instruction. All right. So this is the manual from the Rockwell about the instruction. All right. So but I didn't use the newest version. You can see here, this is 2009 October. I believe the newest one, maybe 2020 or 2000, around that time, this new version. But I use this old version because you'll see that in a moment, it has something with the new version removed. I need to talk about that. All right, so let's talk about the TOF instruction. So this is the instruction. What it's like, it's a box. I already talked about that. All right. So the members and all this we already talked about in different video. I don't want to repeat that. Timing diagram. I even show some of similarity the timing diagram on that, and that's not my concern on this video. The focus on this video is here, the execution of TOF. All right. So that's first. You can see here, that's why I use this version, all right? It has one thing underneath the condition, it called pre-scan, all right? So let's look at here, and then I'll explain, they have explanation on the pre-scan. So with pre-scan, all the control bits are cleared, that's set to 0, right? Then you can see here, that's one thing I want you focus on. I want to talk about more. All right. So the ACC accumulate value is set to equal to the preset value, right? PRE is preset. Like for example, if you want delay 5 seconds, right? That's the 5,000 millisecond. So the ACC is a accumulation. So that's something a little bit weird. All right. I'll explain that. So first, I need to talk about what exactly is pre-scan. Like I said, this version has some old version, right? 2009 has some explanation, but on the newer one, I don't see that, right? That's on page 25. I will move there on here. So underneath the conventions and related term. So they first talk about the run condition in, run condition, run out condition, right? So that's something not my focus over here. So I can maybe zoom in a little bit here. So you can see here, the controller also pre-scans instruction. Pre-scan is a special scan of all routines in the controller. So we understand scan, right? Scan is how the PLC operate. So roughly, if I want to explain that scan is to PLC controller will check the input first, then second step, go to your logic. And then third step, will update the output. Once finish the updating output, we're gonna check the input again. And then after that, scan your logic instruction, update output, right? So that's the normal operation, continue running on there, right? So that's called scan. So this is normal operation in PLC running, but the pre-scan is something the system will do a special one even before anything on your scan happen. So it's like a preparation for the operation on the normal scan, right? So you can see here, controller scan all the main routine, subroutine during the pre-scan, but ignore the jump and skip, and also the for loop. Again, that's not our concern. So I just want to call one of us over here. So you may ask, what's the purpose, right? The controller use pre-scan to reset non-retentive IO and internal values. Again, this is just something the PLC control system trying to get the system ready, right? So notice here internal values that apply to the off delay. Remember, I mentioned that the ACC is being set as the same as preset. We'll have that look at that later, right? Again, all right. So over here, there's something more I want you to know. Over here. So the following condition generate the pre-scan. So whenever you toggle from the program mode to run mode, controller will do the pre-scan. Or if you don't have the program mode, no, that means that the controller is ready going to the run mode right away, right? So that means if you power on and PLC controller directly going to the run mode, right? So that will also do a pre-scan before the normal operation, right? So either you toggle from program to run, or you go to run mode once you power on, right? But anyway, before you first time when you run the logic, PLC controller will do a pre-scan. So let's go back to the off delay pre-scan. So you can see here, that's what we left before, all right? So, well, I think right now, in order to show you this, maybe it's time for me to do a demo. It's better to understand this. All right. So let me open this program on here. So over here, I have a off delay, right? So remember, we just read from the manual. It says the ACC, it will be set is same value as the preset. Right now it says 7,000 as the preset, but we don't see the ACC change to 7,000, right? You can see here, that's my comments over here. Pre-scan set ACC equal to this, right? That's the state of done, right? So I'll explain more, right? But apparently it didn't happen here, right? So how do we prove that? So that's the other thing I want to introduce by using this example. There is a special bit from the PLC. It's called System First Scan. So that you can use this address to access on that. So let me show you how it works. All right. So if we you can see here, if we add a run before this timer, right? So on here, if I check this, the bit I'm going to check is S column FS. So this is a special tag. Yeah, you can see here the tooltip is at first scan bit. So this is system provided a tag. So this bit will turn on when the PLC start the first run scan. Right? But this is not the pre-scan, right? Pre-scan happens before first scan. Let me put it in this way, all right? The first scan is the very first one. I talk about the scan, right? The very first scan in the normal operation in the run mode, but the pre-scan is the one prior before the first scan. All right, so let me show you on here. So what I'm trying to do is that I want you to see the proof with the pre-scan on there. So what I want to do is that anyway, all right, also over here the this, you may see this little bit weird, all right? So what I'm using over here is I'm using a two-dimensional array because I need to use a lot of timers in the following demo. So I'm tired of creating new tags for each timer. So I use a maybe better to show you, all right? So over here, you can see I have this T. This T is a timer type of array, two-dimensional, 5 by 5. So each element within this array is a single individual timer. right? So in this way, so I don't have to create timers for each instruction, all right? So you need to create a different one. I learned that in the hard way, all right? It's a different topic. So over here, I'm trying to use the ACC, all right? So that's the accumulated value from the timer. I will copy that to a tag I created. So what I mean is that when the PLC going to the first scan, I will take the ACC value, copy into here. So that will be saved in there, right? So then you will see how it works, all right? So I need to finalize uh, the uh, the change on here. So still nothing change, right? Nothing say, nothing to prove the pre-scan, right? Because the menu said the accumulate should be 7,000, right? Same as preset. So now let's generate a condition. Remember that every time we change from the program mode going to run mode, we will generate a pre-scan, right? So let's do that. So this, I don't want to go offline and download again, right? So that's going to take a long time. So now I change that to program mode, right? You can see, you notice that green bar on the rail disappeared, right? So now you can see that preset is 7,000, all the others are 0, right? So if we changed that to run mode, you can see here it asks me to confirm. Once I confirm, that's gonna go the pre-scan first. And right after the pre-scan, this first scan will become true. And then by using this move instruction, we can copy whatever on the accumulated value into this one. So then we can see what exactly the value right after the pre-scan, right? So you can see here, when I confirm this, now you see here, right? Still, you don't see the accumulate to 7,000, but I have a proof here because this only turn on for one scan. You will never see this one being highlighted, right? Because it's only happening, it's like a one shot, right? So only the first scan is true. And then by that time, we copy the ACC into this copy. So that's why we got 7,000, right? You can see here, this is right now is 0, right? So that's one thing I try to prove on that. I can prove the other way, but also I want you to understand this first scan because I'm going to use this bit later on in the following demo. All right. So the other way to prove the pre-scan, copy the preset to accumulate, we can do the other way. All right. So let me change that to program mode. Right. Once I change it to program mode, I don't need this first scan. I can delete it. So now if I add a trigger, all right. So first, let me just finalize delete on that. So now I can add a trigger. So this one I already created that. I call that dummy. All right. So because there's nothing to do, not with this one. All right. So let me finalize. So this is another proof for the 7,000 copy on the ACC, all right? So maybe this one is more direct, you can see here, all right? So right now, I have a exam on. This one is false because the tag value is 0. And also the mode is program mode, right? If I change, right? So if I change this program mode to run mode, like I said, right, that will generate a condition to have a pre-scan, right? So we don't use first scan anymore, right? We can directly look at here. So if we change to run mode, if I confirm this time, you see here, you see this accumulate change to 7,000, right? So that's another proof of this this sentence on here. So with the pre-scan, all right, the ACC value is set to equal to the preset value. So another way I can describe this is like a done. it's like a done condition with the timer, right? So why am I talking about this, right? So there's something I want you to know on here. Let's go back here. Right now, you can see here, this trigger is off, right? This trigger is off. We talk about the off delay. Off delay should start timing when the trigger is off, but it didn't. It didn't happen, right? Because when timer is running, you should see accumulation going up, but it didn't. It directly go to the 7,000. That's because the pre-scan, right? So that means for the first time when the trigger is off, which timer should start, but it didn't. It missed time on this one, first one. But the following one is good, right? So you can see here, if I toggle this trigger from off to on, you can see here, when this one is on, it reset the timer to 0. So right now, this off delay is ready to start the off delay timing. So remember that what I talked about before, right? So you have to charge the capacitor in the physical timer in order to let the off delay work properly. Similar things you look at here, you see in here. So you have to make the off delay true for at least one scan, one time, in order to make the off delay happen. Like right now, if I toggle off again, now you can see the timer start. Right, you see that when it's going to 7 seconds, it will change the status. All right, this is running on the emulator, so that's why you see the there's a 17 counts, 17 milliseconds longer than that. It's supposed to be 7,000. All right, so but anyway, all right, so you can see here every time when trigger is true, it reset off delay, but when trigger is off, it start the timing. But if you change that, that will go back to reset on there, right? So this is what I want you to remember as we go along with the following demos, right? Off delay means the first timing if the trigger is off. The reason for that is like I believe that's the reasoning behind this sort of operation, because the I think I mentioned down here, right? Yeah, you can see here, right? Possible reason: the pre-scan put the TOF into done status to avoid starting TOF when power on. Right, even with the false trigger at the beginning, right? So let me explain more, right? So let's go back to the program mode again, right? All right, we're going to program mode. It's not running, all right? So now if I toggle that, right? If I toggle that right now, this trigger is off, right? That's what I mean. False trigger at the beginning, right? This is the off delay trigger being active. The timer supposed to start timing, but Rockwell, I think that apparently they worry about this because all the memory bit is 0 by default at the beginning, right? So if the PLC start to run, very likely this trigger gonna be off. When this one is off, the timer's gonna start. If you let timer start the timing, that's gonna have some consequences, right? They don't want that. They want to make sure you have the timer properly energized for at least one scan, right? Similar to this, to the capacitor being charged. Then after that, you can start to use it, right? So that let me demonstrate again, right? So this is off, right? It's supposed to start the off delay timer, right? Once we change to run mode, right? But we don't see that, right? You can see here, it directly is processed by the pre-scan, set into done state, right? To be safe. So if you want to start to use your off delay, you have to make this one trigger become true at least one scan, right? No matter how short is one scan, it basically reset from the done bit, get ready for the timer. So now from that, if you toggle that off, it will start time delay. Right, so that's the real off delay. All right, so this is just something I want to start with before I am going to do a series of demo. Right, so with the off delay. All right, okay.